Now we're looking at polarity and polar bonds. So the first thing we have to really understand is electronegativity. Electronegativity is the tendency of an atom to pull an electron or electron pair towards itself. So if I have two atoms, they're going to have potentially different strengths or powers to pull an electron or electron pair towards itself. And that's going to be based on this reference. So this is in your reference section. It's electronegativity values. We see that fluorine over here has the highest electronegativity with a value of 4. And then as we work our way to the left and down, electronegativity decreases. So here, if I'm looking at electronegativity values, all I'm going to do is look at my reference and record it. So hydrogen is right here, has an electronegativity of 2.1. So we just have to know how to find electronegativities using our reference. Then when we look at it in the context of a bond, remember a bond exists just between two atoms. So even if there's 3 or 4 or 5 atoms involved in a compound, a bond only exists between two atoms. So when I look at H2O, I'm not worried about the fact that there's 2 hydrogen atoms. And sometimes it helps to just draw a Lewis dot diagram in order to kind of see. When I'm talking about a bond, I'm talking about, in this case, this shared pair of electrons. And all I'm going to do is evaluate their electronegativities and calculate the difference. So hydrogen has an electronegativity of 2.1. Oxygen has an electronegativity of 3.5. So their electronegativity difference, I'm just going to subtract, is 1.4. So that's the electronegativity difference between hydrogen and oxygen in a water molecule. If we look at sodium chloride, sodium, in this case, we have an ionic compound. So again, it's not necessary to draw your Lewis dot diagrams, but sometimes it helps, especially in the case of water, where you might have more than 2 atoms. So sodium has an electronegativity of 0.9. Chlorine has an electronegativity of 3.0. So that's an electronegativity difference of 2.1. So again, when we're talking about electronegativity, this value means that chlorine wants to pull, or has a greater power to pull an electron towards itself. Sodium has a very low value for pulling an electron towards itself. So we see this electron moving to chlorine, creating an ionic bond. Alright, so now we can define our bonds based on those values of electronegativity difference. So if I have an electronegativity difference greater than 2.0, that's ionic. And that's what I see right here in the example of sodium chloride. We already know that we can say sodium's a metal, chlorine's a nonmetal. That makes up an ionic compound. Now we have another way of defining it based on electronegativity difference. If we have an electronegativity difference that's somewhere between 0.4 and 2, then that's a polar covalent bond. So again, if we look at what polarity is the unequal sharing of electrons. If we look back at our example of H2O, because water has a greater electronegativity, this shared pair of electrons right here, those electrons, they're going to hang out closer to oxygen than they are to hydrogen. Because electrons are negatively charged, that makes that side more negative, making this side more positive. And it's more positive because hydrogen's shared pair of electrons aren't there as often. And it has protons in its nucleus, in this case 1 proton in its nucleus, and because those electrons aren't there, it is going to be more positive. So there's a negative side of the bond and a positive side. And the negative side is always towards the element that has greater electronegativity. And then finally, we have bonds that have an electronegativity difference less than 0.4, and those would be non-polar covalent bonds. So if we take a look at something like O2, so we have oxygen, 2 oxygen atoms. Because they're 2 oxygen atoms, they're going to have the same electronegativity, 3.5. Which means each of those atoms are pulling on those electrons to the same degree. They're both trying to pull that electron towards itself. As a result, you end up with a equal sharing of electrons. That's nonpolar. So there is not one side of that bond that is more polar than the other. So in this last section down here, all we're going to do is apply these values to these ranges. So if I look at H2O, H2O has an electronegativity difference of 1.4. That falls in between 0.4 and 2. So that would be a polar covalent bond. If I look at NaCl, NaCl has an electronegativity difference of 2.1. That's greater than 2. So that is an ionic bond. So now we can define our bonds based on electronegativity difference using this reference. Make sure that you use your electronegativity values reference because without it, you obviously can't evaluate these types of bonds based on electronegativity.